Thank you everyone for being here tonight. We are going to go ahead and get started for the sake of time. Welcome to workshop number 1 of Soil Smarts, DTSC's interactive learning series on the soil cleanup at SSFL. My name is Dr. Jamie Slaughter, and I am the DTSC Public Participation Manager, and I will be facilitating this workshop. Thank you for participating this evening. Tonight, this meeting is being recorded. We ask that you please be courteous to all meeting attendees. When providing input or asking questions verbally, please speak clearly and at an even pace. Each participant will have 2 minutes to ask your question, and you will get a 30-second warning. You may also type questions or input into the Q&A section throughout the meeting. You can see your Q&A at the bottom of your screen. And please note that you may be muted if necessary. Soil Smarts Workshop Series is designed to help all interested parties understand the steps that we are taking regarding soil cleanup at SSFL, especially the efforts by NASA and the Department of Energy to ensure soil is cleaned up to local background levels. Our first session tonight will provide an overview of the SSFL soil cleanup and dive into the background cleanup requirements for soil for the DOE and NASA areas. We aim to give you a clear view of the site's cleanup history and activities this evening. DTSC will answer your questions and gather your input tonight and throughout the series. The Department of Toxic Substances Control's mission is to protect California's people, communities, and environment from toxic substances, to enhance economic vitality by restoring contaminated land, and to compel manufacturers to make safer consumer products. DTSC respectfully acknowledges that we conduct our work on the unceded indigenous lands of over 200 distinct Native tribes within the state of California. DTSC recognizes all California Native American tribes, regardless of federal recognition. We honor the indigenous communities who have stewarded this land for generations, and we recognize their enduring relationship with the land, waters, plants, and animals that are integral to their culture and heritage. In acknowledgement of these tribes, we strive to approach our work here with respect for the historical and cultural significance of this area. Before we get started, please join me in welcoming our DTSC Director, Katie Butler, for opening remarks. Since 2023, Katie served as Deputy Director of the Hazardous Waste Management Program at DTSC. Prior to joining DTSC, Katie served as Senior Health Deputy in the Office of Los Angeles County Supervisor, Janice Hahn. Welcome, Director Butler.
Thank you, Dr. Slaughter. Good evening, and thank you all for attending our workshop. I am grateful for this opportunity to serve as the new director of DTSC. I take our role very seriously here at DTSC as the lead regulatory agency overseeing this cleanup. Our responsibility is first and foremost protecting the environment and public health. So as director, I'm committed to making some meaningful changes, and I'd like to take this opportunity to share with you all 2 of my priorities in this leadership role: enforcement and collaboration. These are 2 key aspects of our work that have proven to be successful in my career up until this point. As you heard, I worked for Los Angeles County before coming to DTSC. I coordinated joint enforcement agency teams at the county level, working closely with community partners to combat pollution in environmental justice communities. This is the work I'm passionate about, and I believe that the work that we do as a regulator is stronger when we work collaboratively. So some of the best enforcement cases that I've worked on have come from community reports, because it's the communities that are the eyes and ears for us on the ground. So we value your input and we value your participation. I had the chance to visit Santa Susana Field Lab a couple weeks ago, along with our new Deputy Director, Than Berg, and that gave us a much better understanding of the ins and outs of this site, the challenges we're dealing with, and opportunities that we have to navigate those together. So with the dedication of leaders like Director Thanberg and others on this team, we're focused on taking decisive steps forward, and we're also committed to doing this in a way that involves the community, and we move on this journey together. Than came to us from DTSC. I'm very grateful. She's on our team now. She was previously serving at the United States Environmental Protection Agency, where she spent more than 27 years focusing on protecting human health and the environment. Her many roles there align with our priorities at DTSC, and they perfectly equip her for her role at DTSC. So I'll turn it over to Than, and she will provide an overview about the cleanup efforts and Santa Susana.
Thank you so much, Director Butler. Glad to be here. So to start off, we want to talk about, before we go into all the technical discussion, we wanted to give an overview of where we are at Santa Susana Field Lab. So for a few slides, just join me as I go through this for those who don't have much familiarity with the site itself. Okay, next slide. So Santa Susana Field Lab is roughly 2,850 acres. The site overlooks Simi Valley to the north and northwest, and the San Fernando Valley to the southeast. The site is located in the Simi Hills area of Ventura County, approximately 30 miles northwest of downtown Los Angeles. As Director Butler said a few minutes ago, she and I visited the site recently. We were both struck by the size of the site and the overall beauty of the land. The natural ecosystem supports diverse wildlife. We saw some deer, which was really cool, and threatened and endangered species. We also observed tribal cultural resources. So it really is a striking piece of property, and seeing it in person really put things in context. Okay, next slide. Okay, SSFL history. Since 1947, rocket engine testing and nuclear research took place at Santa Susana Field Lab, leaving behind both soil and groundwater contamination. The chemical contaminants include a variety of solvents, primarily trichloroethylene or TCE, metals, perchlorate, and petroleum hydrocarbons. Radionuclides from nuclear research activities have also impacted the area. Okay, next slide. There are three responsible parties at the site. The Boeing Company, or Boeing, the U.S. Department of Energy, and the National Aeronautics and Space Administration. Boeing is responsible for soil cleanup in areas 1 and 3 and the southern buffer zone, and it is identified in blue on the slide before you. DOE is responsible for soil cleanup in areas 4 and the northern buffer zone, and it's identified in the green. And finally, NASA is responsible for soil cleanup in area 2 and a small portion of area 1 shown in orange. The map clearly shows where each party is responsible for soil cleanup. However, there's some overlap and shared responsibility for groundwater cleanup. For example, in Area 4, Boeing and DOE both have shared responsibility for groundwater there. All right, next slide. Environmental contamination. Santa Susana's Field Lab's operations released various chemicals and radiological contaminants affecting soil, bedrock, soil vapor, and groundwater. Since 2007, Boeing, NASA, and DOE have collected samples from over 15,000 locations, with many locations having samples collected at multiple depths. In addition, there was a 2-year radiological survey conducted by US EPA and the DOE Area 4 in 2010 to 2011. That survey involved the collection of 3,700 soil samples and 120,000 analyses. That sample characterized the on-site extent of nuclear radionuclides. So needless to say, with that amount of sampling, contamination is well characterized at this point. In addition, DTSC and the Los Angeles Water Quality Control Board require ongoing groundwater, air, and stormwater monitoring. Okay, next slide. So we have three different agreements, enforceable agreements that are between DTSC and the responsible parties. The corrective action consent order from August 2007 requires a risk-based cleanup and applies to site-wide groundwater for the three responsible parties. There's a 2010 administrative orders on consent, and that agreement is in between DTSC and only DOE and NASA. And it requires a cleanup of chemicals and radionuclides in soil to background levels. The third is the Boeing settlement agreement from 2022. It requires Boeing to clean up chemicals in soils to a risk-based standard, and it's a very stringent risk-based standard that would make it safe for someone to live on-site and eat produce grown on an on-site garden. That settlement also requires Boeing to clean up to background for radionuclides. Okay, next slide. Okay. Our goal is to implement a soil and groundwater cleanup that is protective of human health and the environment. This is a large, complex project on a stretch of land almost 3,000 acres in size, with an abundance of biological and cultural resources. We want to ensure that the cleanup of contamination caused by the RPs, the responsible parties, happens while preserving the natural ecosystem affected by the responsible parties' operations. As required by the California Environmental Quality Act, DTSC evaluated the cleanup project and certified the final project environmental impact report in July 2023. In that report, DTSC evaluated the potential environmental impacts of the cleanup under the current methodology of the administrative orders on consent and made no exceptions to biological or tribal cultural resources. This was an attempt to identify potential impacts if an extensive excavation of soil occurred. The results was an estimated approximately 2.5 million cubic yards of contaminated soil would be removed. To put things into perspective, 2.5 million cubic yards of soil would fill the entire Pasadena Rose Bowl 2.5 times. And it would require 96 trucks per day for 15 years. That's a lot of soil, and that's a lot of trucks. Next slide. So though we have not gotten to final cleanup at Santa Susana Field Lab, there are several important discrete cleanups we've conducted at the site for purposes of ensuring that people and the environment are protected. There have been 15 interim soil cleanups completed already. There is an ongoing groundwater cleanup under the groundwater interim measures and the DOE area of responsibility. Those actions are ongoing, and extracted water is disposed of off-site. All three responsible parties have demolished and removed numerous buildings and infrastructure to prepare for the soil cleanup. Boeing is required under 2 imminent substantial endangerment orders to clean up the former shooting range and the Area 1 burn pit. And both of the actions under these orders is scheduled to be concluded and finished by the close of this year. Next slide. To ensure that residents are informed and to involved in all the decisions that we make at SSFL, DTSC has done many things to try to incorporate that public participation, including public meetings, workshops, and site tours. We also respond to public inquiries, conduct surveys, and provide regular community updates. DTSC has hosted a public meeting to take public comments in the Area 1 burn pit removal action. Public comments and concerns were incorporated into that final work plan. We have also hosted listening sessions to ensure all voices are heard and educational workshops known as Groundwater U to support our stakeholders as they make informed and productive comments on upcoming groundwater documents. Next slide. This slide represents the anticipated timeframes for public comment periods for cleanup decisions. It's important to recognize the significant planning and public process that is required prior to approving any of these decision documents. The first groundwater decision document is anticipated to be released for the public comment in winter 2025, and that will be for NASA Phase 1. The first soil decision document is anticipated to be released to the public for comment in summer 2025, and it is for the Boeing area of responsibility. Next slide. Okay, well, this is coming to the conclusion of my quick overview of where we are on Santa Susana Field Lab. But before we go on to the more technical discussion, I just wanted to share some of the guiding principles that DTSC is holding as we're looking at decisions coming up. First principle is that we want to hold responsible parties accountable. We want to clean up based on background standard to protect human health. We also want to address all the contamination caused by their operations. Second, we want to make sure we ensure that the cleanup happens while preserving biological and cultural resources. That means protecting natural ecosystem and wildlife, protecting threatened and endangered species, and protecting tribal cultural resources. And finally, I know that everyone is anxious to get to final cleanup. We definitely want to make sure that we're moving that way as quickly as we can while making informed decisions. So with that, I want to thank everyone for coming tonight, and I'm going to turn it back over to Dr. Slaughter, who will lead us to the next part of our presentation. Thank you so much.
Thank you so much, Deputy Director Than Berg and Director Katie Butler. And now we will transition to the workshop presentation. To present on DOE and NASA's background soil cleanup at SSFL, I would like to introduce Dr. Valerie Hanley, Senior Toxicologist at DTSC, with our Human and Ecological Risk Office, HERO, for the Santa Susana Field Laboratory project site. Dr. Hanley?
Thank you so much, Jamie. Let me get my slides pulled up here. All right, here we go. Well, thank you again for the introduction, and thank you to Director Butler for her opening statements, and to Than Berg for her overview of Santa Susana. I'm really pleased to be here tonight to talk to everybody about this very important cleanup at the Santa Susana Field Laboratory. As Jamie mentioned, I am a senior toxicologist in our Human and Ecological Risk Office. I am a new face to many of you tonight, and so I wanted to take just a moment to introduce myself. I have been on the Santa Susana Field Project for just the last 2 years, but I have been with DTSC. I just reached my 16-year anniversary last week with the department. I have just really enjoyed my time with the department. It feels really good to me to be able to tell people that my job is to protect the people of California, to ensure that sites get cleaned up so they are protective and so that they are safe for our families and children to go to school, to play, to live, to grow up, and for people to work on. I'm very passionate about this work. It's what keeps me in state service. I feel good telling my children about the work that I do. I am a mom to 4, and this job has gave me great life balance, but also so that I can tell my children that I do good work, and I'm leaving this world a better place for them. I truly believe in that work and that that's what we're doing. And so I'm really excited tonight to talk to you all about this background cleanup at Santa Susana and present some facts. And this is going to be a very technical presentation, and I apologize for that up front. because it's going to be a lot of information, but we really want to take this time to help the public really understand the technical details that we are looking at, and that we need to find some solutions for some issues that have come up in being able to achieve this background cleanup, which DTSC is committed to this chemical background cleanup. And that's why we've called this Soil Smarts education, an interactive learning series, because we really do hope that at the end of this series that you will feel better informed and be able to help us make some decisions on how we move forward. I do want to remind everyone that the presentation is being recorded tonight, so you will have the opportunity to go back and to watch this again. So while it is a lot of technical information, this will not be your only chance to receive it. Additionally, we have created a series of fact sheets and videos regarding each of the key concepts that I'm going to be talking about tonight. And those will be posted on our website and made available after our workshop. And so we hope that all of these materials will help you in understanding everything that we're talking about. And, we understand that everybody learns a little bit differently. And so hopefully between all of these different materials, we will have found a sweet spot that helps you to understand. And with that, I'm going to go ahead and jump into my presentation. So the first thing that I want to note is that we are focused on the chemical soil cleanup to background, to local background levels at NASA and DOE. This presentation is not going to discuss radionuclide cleanup to background. The cleanup to radionuclides do not present the same technical issues that are associated with the chemical cleanup. Radionuclide contamination is being addressed according to the requirements of the AOCs for NASA and DOE, which do mandate the cleanup to background. And that is what we will have for radionuclides as well as our chemical cleanups. Okay, so here's a little bit of a roadmap to take you through, to let you know what the journey is that we have ahead of us. We're going to start out by talking about those legal agreements, the AOCs that guide the work. We're going to talk about DTSC's background study, the chemical background study. We're going to talk about the current approach as outlined in the AOCs for this background cleanup. We're going to talk about how the chemical lookup tables were developed. And we're going to talk about some of these technical issues that have arisen that we need to figure out so that we can get this background cleanup completed. And then finally, we're going to talk about a proposal. It's going to be a new approach that we're proposing, but this is just one idea that we have on how to move forward, and we really hope that the public will help us in coming to these next steps, and will provide a lot of feedback on this approach and potential other approaches. Okay, so let's start out with those legal agreements. So as we've mentioned before, the Administrative Orders on Consent, or AOCs, were signed in 2010. These are the legal contracts between the responsible parties and DTSC. NASA and DOE have separate AOCs with DTSC, but they have the same basic requirements. So what are the AOCs? These are the legal contracts that define the requirements for the investigation and cleanup within the NASA and DOE areas for Santa Susana. The AOCs require that these areas be cleaned up to levels consistent with local background. DTSC has a number of obligations within the AOCs. We were to complete a chemical background study, which I will be talking about in a little bit, to determine those local background levels. We were required to create a lookup table with chemical cleanup levels. And also it goes on to state that we are to determine the best option available when presented with confirmation sampling results that exceed lookup table values. Okay, so those are the legal contracts. So we're going to jump into the DTSC chemical background study. The chemical background reference locations were identified with public input. I'm sure some of you that are on this call tonight were involved in that process. Residents were able to walk the different reference location sites that were potentially available to use. And once they were actually chosen, many residents were even present for the soil sampling. There were a number of parameters that needed to be met when we were choosing these locations. We had to make sure that they were within the same geologic formation as Santa Susana, because the underlying geology or the rocks that underline the soil have influences on the naturally occurring chemicals in soil. So we needed to make sure that we were in the same geologic formation. We had to make sure these sites were not impacted by potential airborne impacts from Santa Susana. So we know that they do not have chemicals from Santa Susana present. They needed to have a similar fire history, because we know with wildfires, which unfortunately we've all experienced many recently, they do come with certain chemicals that are associated with fires. And so we needed them to have similar fire history. And then we had to have them undisturbed by industrial activities. And of course, they had to be accessible for us to be able to go and access the properties and sample the sites. There were 2 chemical background reference locations that met these required standards: China Flat and Wood Ranch, which are shown here in pink in relation to the Santa Susana Field Laboratory. China Flat is approximately 3 miles west-southwest from the SSFL border, and Wood Ranch is approximately 4 miles from the western border of Santa Susana. A total of 295 soil samples were collected from these 2 chemical background reference locations. We see Wood Ranch on the left and China Flat on the right in these maps that are on the screen. These 295 samples represents a very robust background data set. Oftentimes we're using 8 to 10 samples to look at background in other sites in California. So 295 is a very robust background data set. The soils from these areas represent the standard we are looking to achieve with the NASA and DOE soil cleanups. These are the local background that we are cleaning these areas up to. So in 2013, DTSC used the data from the chemical background study to develop the 2013 chemical lookup tables, which have values for more than 130 chemicals, some of which were part of that background study and some of were not. And I will get into more details about the different kinds of values that are represented in the lookup tables in just a moment. Okay, so with a little bit of history about the DTSC background study, the next journey in this trip is for us to talk about the current approach. And I'm going to spend a little bit of time talking about the difference between the AOC approach, the approach that is discussed in the confirmation sampling protocol within the AOCs, and the standard approach that we use on most sites in the state of California. So establishing the lookup tables was, of course, the first step using the chemical background study. But then we needed to actually look at the AOCs about how these lookup table values will be used. So remember, those lookup table values represent local background, and the AOCs say the residual concentrations in soil are not to exceed local background, that they will not be averaged with other soils. And they also state that risk assessments will not be required, which is, the standard practice that we have in most sites here in DTSC. So in these next couple of slides, I'm going to compare that not to exceed approach that is outlined in the AOCs to DTSC's typical site cleanup approach using risk. So in this image on the screen, we see an example site that has similar topography to Santa Susana. There's a structure near the top of the hill that represents a source area for chemical contamination. Samples were collected throughout the source area, including locations downhill, to account for the potential transport of contaminants. In this example, the size of the circle represents the concentration of the chemical. So the larger the circle, the higher the concentration. So we're going to zoom in to this outlined area here to get a little bit of a closer look. And first, we're going to consider a typical risk-based approach, which we use here in California. In this example, we would consider the outlined area to be representative of an exposure area. This would be an area that a receptor, such as a future resident, would be in regular contact with. When we do risk assessment, we typically calculate what's known as an exposure point concentration, or an EPC. This is an estimate of the average concentration that a person would have contact with over a period of time. And then that EPC, or exposure point concentration, is compared to the health protective cleanup goal. In typical risk-based cleanup, we consider the future land use. Unrestricted land use is typically granted if the site is cleaned up to a residential standard. The exposure area is considered to be the residential property. It considers the toxicity of the chemicals that are present, as well as the exposure area, which, as I mentioned, is like the residential property for a residential exposure. It also takes into account the exposure frequency and duration of those exposures. So for residential exposures, we typically consider that to be 26 years. This accounts for 6 years as a child and then 20 years as an adult. This is our standard practice for risk-based cleanups in the state of California. It also assumes that exposure is happening 350 days per year. Our risk assessments allow us to take a 2-week vacation, or assume that we might not be at our homes for 2 weeks out of the year. And finally, we do take soil ingestion and inhalation and dermal contact. But for now, I'm going to focus mainly on soil ingestion. This does assume that there are a total of 7.5 cups of soil that would be ingested over that 26-year period. So this is the information that we use to inform our risk assessment for a residential cleanup. So back to our example site. We would take the calculated exposure point concentration and compare it to our health protective cleanup goal, to see if a person would be exposed to more than the acceptable risk. If the EPC, or the exposure point concentration, is greater than that health protective cleanup, then targeted soil removal would happen to remove the highest concentrations of contamination. The remaining concentrations would be averaged to ensure that they are below the health protective cleanup goal. That's our standard approach. But now let's look at what we talk about in the AOCs. We just want to give you guys an idea of the differences between what we typically do and what we have planned here for Santa Susana. At Santa Susana, using the not to exceed approach, here we're considering the exact same scenario. We have the same concentrations of a chemical, but now we're using that not to exceed local background approach to evaluate if any soil removal is needed. And our cleanup goal now, instead of being that health protective goal, is our lookup table value, which represents local background. So in this not to exceed cleanup, any detection above a lookup table requires soil removal. So if a lookup table value is 2.4 micrograms per kilogram, and there's a detection of 2.5 micrograms per kilogram at the site, then those soils would need to be removed. In this example, all of the samples had at least one detection greater than the lookup table. It is important to remember that the lookup table values are not risk-based. So there's no consideration given to the future land use, exposure frequency, exposure duration, or even the toxicity of the chemical. For example, one of the chemicals evaluated in our background study has a lookup table value of 2.4 micrograms per kilogram, while the residential health protective screening level is more than 1 million micrograms per kilogram. Many of our lookup table values are several orders of magnitude below our risk-based screening levels. Of the more than 130 chemicals that are listed in the 2013 lookup table, the average lookup table value is more than 300,000 times lower than our health protective screening levels, considering residential use. Some of them are more than 1 million times lower than those screening levels. There are 5 lookup table values that are above our health protective screening levels. Those are all for naturally occurring metals that are often found above screening levels within California soils. So in summary, in a typical risk-based cleanup approach on sites in California, they will have a focused soil removal in areas with the highest concentrations of contamination. Residual concentrations are averaged and compared to health protective value. Using a not to exceed background cleanup, there's a much greater volume of soil removed based on any detection above a lookup table value in any individual sample. While this results in a reduction of chemicals in soil, it results in a much larger soil cleanup than is necessary to be protective of human health. Many of the lookup table values are well below our risk-based screening levels, as mentioned previously. Now, that is, of course, by design, as we are doing a cleanup to background, but it should be acknowledged that significant cleanup may be required of soils without a measurable added benefit to the protection of human health. In fact, it would result in significant destruction of critical habitat for several endangered species and cultural resources, as the entirety of the Santa Susana Field Laboratory is considered sacred land to several Native American tribes. The current lookup tables paired with the not to exceed approach would result in significant soil removal. Okay, on that note, I want to talk more about these chemical lookup table values. These are the values that represent our local background. And I'm going to talk about how they were developed and some of the decisions that were made by DTSC in setting the lookup table values using the data from the chemical background reference areas. So again, these chemical reference or the chemical lookup table was released in 2013, and it was set for established for use in characterizing the extent of the contamination in soils in the NASA and DOE areas of Santa Susana. I'm going to discuss the next few slides how those provisional values were derived and how they may require some modifications based off of current laboratory capabilities. So there are three different types of values that are represented within the chemical lookup table. The lookup table represents local background levels as well as method reporting limits for chemicals that were not detected or that were detected infrequently in the background data set. So I'm going to be discussing each of these different types of values that are within the lookup table. And so you'll have a better understanding of how each one was developed. So first, we're going to start with the ones that were developed using data from the site, from the background reference area locations, And these are known as the BTV or the background threshold value lookup tables. I know there's a lot of acronyms. I'm going to try my best to not ever say an acronym without saying it out loud, but I do want you to get used to the different terms if you're not already, because they will be used in our upcoming documents and they are used in the lookup table. And so they can aid you in being able to understand these resources if we also teach you the acronyms. Okay, so the BTV or background threshold value is an estimate of the upper limit of background concentrations within our soils. 52% of our lookup table values are based off of a background threshold value. So these are based on concentrations that were detected in the DTSC chemical background study soils, and they were developed using statistics. So I'm going to use an analogy to help explain how we use the data from the background study to develop the lookup tables. So we're going to think of our background soils as a giant cookie. So I understand it might seem odd that we're using food as an example, especially when we're here talking about cleaning up a contaminated site. But my hope is that by using a familiar item such as a cookie, that it's going to help explain some of these abstract ideas in a way that's easier to understand. So most of us have eaten a cookie or made a cookie using a recipe. And so I'm hoping this analogy will be a helpful explanation of how we use the data from the background reference area soils to develop our lookup table values. So in this example, again, we're going to consider that the cookie represents those background reference area soils. Remember, that was China Flats and Wood Ranch, these areas that we chose with public input and where we collected all of those samples. That the cookie represents our background soils, and the candies in the cookie represent a chemical detection in our background soils. The size of the candy represents the concentration of the chemical. So the larger the candy, the higher the concentration. So in this example, we are considering a single chemical as represented by the blue candies. In this candy, you can see that, or I'm sorry, in this cookie, you can see that one of the candies is much larger than the others. And we refer to this as an outlier. In our background soil samples, outliers are chemical concentrations that are significantly higher than the others, as shown in this chart using arsenic as an example. So these could be significantly different, like we see in this data set, or they can be a smaller difference as seen in this other data set. But ultimately, these outliers can skew the results of our background threshold value concentration. So because of that, when the background threshold values were calculated for the background soils, the outlier concentrations were removed from the data set. And this decision resulted in a lower calculated lookup table value, as represented by this smaller blue candy, which is much smaller than the largest detection, the largest blue candy that we saw in our cookie. Okay. So I'm hoping that that is a little bit helpful in explaining how this was done. So this was again done for 52% of our samples were based off those BTVs. So those are detections from our chemical background study. The next type of lookup table value that I'm going to talk about is known as a BG MRL, or the background study minimum method reporting limit. The method reporting limits are the lowest concentration of a chemical that can be reliably reported by a laboratory. So this can vary by laboratory to laboratory and even from sample to sample due to influences of the soil. I want to note that special methods were used by DTSC in our chemical background study to achieve the lowest possible reporting limits. And this was done because we wanted to make sure that as we're doing site characterization, we're really reaching those background levels. So these lookup table values for the background minimum method reporting limit were used for chemicals that we analyzed for in the background study, but they were only detected in a handful of samples. So you can see on this map that the orange squares represent a chemical detection, and they're sporadically located in these two different locations. And so there wasn't enough data there for us to do the statistics to develop the BTV. And so because of that, we defaulted to using a method reporting limit. Okay, so here is a scatter plot, and I know this is a messy figure and this is very technical, but I'm going to walk you through how to read this, and I hope that it helps you understand the data a little bit better. I found this really useful when I joined this project and really trying to understand how the lookup tables were established, kind of how we were having some of the issues that we were seeing. Okay, so this is a scatter plot for a single chemical as measured in the DTSC background study samples. So each dot that you see in this figure represents a single sample. And the position of that dot on the y-axis, or that vertical line on the left, represents the concentration in micrograms per kilogram. So the blue squares are detections, and the orange dots are non-detected values that are shown at the reporting limit for that sample. So as you can see, the reporting limits really varied for each sample. They range all the way down from the bottom of the scale at around 1 microgram per kilogram, all the way up to closer to about 28 micrograms per kilogram. So there's quite a variability. The other thing we're noting on this slide is the lookup table value itself for this chemical, which is shown here. And that was based off of the lowest background method reporting limit. That's where that BG MRL, that background minimum method reporting limit, that's what we set that on. But as you can see, there are 9 detections there were 9 detections of this chemical in our background soil samples that are above that lookup table value. That's all of those blue squares above that blue line. Okay, So we're back to our cookie analogy. Hopefully this is helpful. And I'm going to explain using the cookie how this works with the background minimum method reporting limit. So again, this cookie represents our background samples, or our background soils. And now we have different colored candies, and these different colors represent different chemicals. So the chance that you're going to get a red candy in a bite of cookie is lower than getting a yellow, blue, or green candy in a bite of cookie, even though the red candies are part of our cookie recipe and they're supposed to be there. They're not contamination of our cookie. They are part of our ingredient, but they weren't found very often. Similar to how our chemicals that have a lookup table based off of the background minimum method reporting limit were in fact detected in our background soils in the background reference areas. However, because they were only detected in a few samples, that background threshold value statistic could not be calculated. So we defaulted to using that lowest reporting limit to establish the lookup table value. Oops. Using our cookie analogy, you can think of this reporting limit as the smallest piece of red candy that you could reliably see in the cookie. That lowest reporting limit was then achieved for the chemical, was then used as the lookup table value, just like the smallest piece of cookie would then be used as our method, as our lookup table value, which you can see is much smaller than the actual detections in our sample or the actual candy size that we used in our cookie. Okay, so the third and final type of lookup table value was based on a multi-lab method reporting limit, or an ML-MRL. These were used for chemicals that we did not assess in the chemical background study. So they don't truly represent background. What they represent is a limit that we should be able to reliably see from labs. And really what we're wanting to see when we do a cleanup to background is that we don't have any detections above this method reporting limit. To set these lookup tables based off of the method reporting limit, we surveyed multiple labs and we determined what the lowest achievable MRL was for each given chemical, and that value was used for the lookup table value. So this is, I'm going to summarize what I've talked to you about so far and leave you with some key messages before I give you a short break, because I know this is a lot of information that we're giving you today. So again, the key messages I want you to take away from the first part of this presentation is that DTSC is committed to the chemical soil cleanup to background. We did a robust chemical background study to establish local background. The community was very much involved in that process and, felt good about the locations that we picked. We feel very confident in those locations and the data that came from that. The provisional lookup tables were forced as low as possible to aid us in site characterization at the Santa Susana Field Laboratory. Given all of that, using the not to exceed approach that is written into the confirmation sampling approach in the AOCs would lead to significant destruction of habitat, the environment, and cultural resources without a measurable benefit to human health. Of course, removing contamination benefits human health, but the excessive amount that would be removed using this approach does not result in a measurable additional benefit to human health. And so with that, we are going to take a 5-minute break. It is 6:50 right now, so we will start back up again at 6:55. I know this was a lot of information, so I encourage you to take this time to stretch your body. I'm going to get a drink of water, do whatever you need to do so that we can come back at 6:55 and continue on with the technical presentation. All right, I see we are at 6:55, and so in the interest of time, I'm going to go ahead and start back up. Hopefully everybody got a stretch, a drink of water, and just was able to relax a little bit. So we've gone through the legal agreements, the AOCs, the contracts that direct us on how we're going to do this cleanup to local background. We've talked about the DTSC chemical background study. We've talked about the current approach, the not to exceed background level cleanup approach, and how our chemical lookup table values were developed. And so now we're going to get into some of the meat of what the technical issues are. So let's jump into that. So one of the biggest issues that we have seen is that this not to exceed approach paired with our lookup table values results in the misidentification of soils as contaminated when they are not. More than 50% of the samples that are collected from the DTSC chemical background study fail if we use the not to exceed comparison approach to the provisional lookup table values. This is what's known as a false positive error. These are our local background soils. This is what we are trying to clean up to. And 50% of those samples can't pass our test. So we're going to talk a little bit more about these false positives and exactly what they mean and walk you through some of this data. So again, a false positive is when soils are identified as contaminated when they are not. So that means that we would have a chemical detected above its lookup table value, but it is not due to site activities, right? This is the case in our background study soils. So we're going to go back to our cookie analogy and think about what this would look like, how these false positives would look like in our background cookie. So again, remember, here we are at our cookie that represents our background threshold value. These are the values that were developed using detections from our chemical background study. And so now we're going to apply the AOC approach, that not to exceed approach, to our cookie, meaning our soils and our background locations. Each bite of the cookie, if you will, would be like a soil sample that we would take. So one of the bites of this cookie would fail the comparison to our lookup table value because it has that outlier concentration, right? That outlier candy, is larger than our lookup table value. This is a false positive result. We are identifying the largest blue candy as contamination, even though it was an ingredient in our cookie recipe. Just as we'd be identifying those detections from the chemical background study as contamination, even though those soils are our local background levels by definition, right? So we excluded that as an outlier, but that's a true detection within our chemical background study. So, but that would fail the comparison to our lookup table. Now let's look at this again using our lookup table values that are based off of that background minimum method reporting limit. So remember, these are for those chemicals that were assessed in the chemical background study, but that were infrequently found. So, and each of the, remember the cookie again represents our background reference areas, and the different colors are different chemicals, right? And the grid that overlays this image represents either a soil sample, if this was soil, or a bite of the cookie that we're going to take. Now, 2 of these bites of these cookies are going to fail. They have a red candy that's present that is much larger than the lookup table value. But that lookup table value, remember, was based off that smallest red candy we could find in our cookie. And this is just like it would be if these were our soil samples, and we would be identifying those infrequently detected chemicals from our background study as being contamination, even though they were a part of our cookie. So these are false positives. They are falsely identifying the red candy as contamination, even though they were an ingredient in our cookie recipe and they were supposed to be there. So hopefully the cookie analogy helped. Some of you may be confused by the cookie analogy, or, it just didn't work for you. And so we understand people understand things in many different ways. And so we're going to actually use our real data and show that to you. And so hopefully one of these lands with you, maybe all of them. And we're going to continue to try and help you understand this. So DTSC applied the not to exceed approach using the current lookup table values to our background soil samples. So these are the samples again. They represent our local background. These are the standard we are looking to achieve. But what we did is we pretended that they were like site samples from Santa Susana to determine if our method would appropriately identify them as being consistent with local background. Okay, so to do this, again, here we have our maps from Wood Ranch and China Flat. A reminder that we had 295 total samples that were collected from these areas. They were tested for 111 different chemicals. These chemicals include things such as metals that are naturally occurring in the soil, and then also things like herbicides and pesticides and other things that might have been deposited through the air, through fire history, all of these things that create different chemicals in soils that are present, throughout the state of California and really everywhere. But this is our local background here, very close to Santa Susana. So 63 of our 295 samples have at least one detection greater than a lookup table value. So remember, the lookup table values were developed using this area. These soils represent that background standard we are looking to achieve. So these detections in these 63 samples represent a false positive error when they're compared to our lookup tables. These are consistent with local background, yet our method shows them as failing. If these were site soils, they would have to be removed. This is, again, that's a false positive. There were a total of 48 different chemicals that were detected in those 63 background soil samples above a lookup table. As a side note, none of those chemicals were above our residential health protective screening levels. So using our scatter plot that I've shown before, we're looking at a single chemical from the background study again. So we can see that these blue squares that are circled in red represent the detections above the lookup table value, right? Which is indicated by that blue line. So we have these 9 samples that are circled. There's 7 circles, but there's 9 samples in there for this particular chemical that are above our lookup table value, and they would fail using our current approach. So again, our 295 soil samples, 95 of those samples have a non-detect value with that value, that non-detected value, the reporting limit for that particular sample above our lookup table value. So back to our trusty scatter plot. This is all of those orange dots that are above this blue line. So remember, the reporting limits really varied a lot from sample to sample. This has to do with the soil influences, and also because remember, we were using those special methods to try to drive our reporting limits as low as possible. And when you drive reporting limits low, you increase that error, that noise in those lower concentrations. And so it's very hard to get a repeatable result. And so all of the orange dots in this shaded area represent samples that would fail our comparison to the lookup table value, even though that chemical was not detected in those samples. These are non-detected values. They're just shown at the reporting limit. But because the reporting limit was above the lookup table based off of the MRL, those fail the comparison to our lookup table. So again, these are false positives. So that means that these 95 samples would fail the comparison to our lookup table without the chemical even being detected in those soils. So in summary, we found that 158 of our soil samples from our chemical background reference areas fail the comparison to the lookup table values. And this is a 54% failure rate. If these were site soils, using our current lookup table and the not to exceed approach would require that they be removed, even though these soils are local background standard we are looking to achieve. In summary, our lookup table standards are so strict or so low that even our background soils cannot meet those standards. And these are the background soils that were used to develop the lookup tables, right? They should absolutely pass. They are the standard we are looking to achieve, but we have a 54% failure rate. That shows us that we need to think of another way to move forward. So how do we normally deal with false positives environmental data? False positives aren't unique to Santa Susana. They aren't unique to our background reference areas. They're common, but how do we typically deal with them? Well, the first thing we do is risk assessment. Risk assessments, use statistical averaging. They consider the toxicity of chemicals in that exposure area, as I talked about earlier. But as we know, the AOCs say that the development of risk assessments will not be required. They also use statistical averaging within an exposure area, but the AOCs again say that we will not be averaging soils together. And the AOCs also say that confirmation soil sampling shall include all contaminants within an analytical suite associated with the contaminants of concern identified for that source area. Okay, so what does that mean? So far in our cookie analogy, we were focusing on lookup table values for an individual chemical. But remember, there are lookup table values for over 130 different chemicals that we have to consider in our AOC cleanup to local background. And each chemical comes with its own false positive error rate. And while that rate is relatively low for individual chemicals, the more chemicals we analyze, the higher the chance we have of receiving a false positive and misidentifying soils as contaminated when they're not. So to demonstrate this compounding error, I'm going to be using another analogy, and this time I'm using dice. Dice are very commonly used when teaching math in school. They are, again, something people are familiar with. So I'm hoping that explaining this using dice will be a helpful analogy. I've definitely helped my son with math problems involving dice. So let's jump into it. So in this example, we can think of rolling a 6, like there being no false positives. So if we roll a 6, that means that our answer to that sample is correct. If there is a detection in there, it's due to contamination. If everything is below lookup tables, it is it's local background, right? So we're not going to have any false positives. So that's rolling a 6. So if we have just a single die and we roll it, the chances of getting 6 are 1 in 6. So we have a 17% chance. If we have 2 die, then our probability of both of those landing on a 6 or neither one of them resulting in a false positive drops down to 3%. And as we add more die, this gets lower and lower. And so by the time we get to 5 dice, and I personally stopped at 5 because I love Yahtzee. I play it with my family a lot, and I have since I was a child. And so I like the number 5. But when we get down to 5 dice, the chance of all 5 of them landing on a 6 drops down to less than 0.01%. So the more chemicals that we're analyzing in these samples, the higher the chance we have of a false positive, particularly with low lookup table values. So the odds are different, but this is essentially the analyte by analyte within a sample approach that we use at Santa Susana using the not to exceed approach. Because our lookup table values are low for many chemicals because of how we set them. And we also have the MRLs that sometimes are not always consistently achievable, as you can see the variability in those scatter plots. The chances of one of those chemicals failing the comparison to a lookup table value due to a false positive increases to almost 100%. And our site-wide false positive error rate goal is to be less than 5%. So this is really an issue that we need to deal with. So as we've been discussing this issue of false positives, You may have been thinking to yourself, so what? Isn't more soil a good thing? Won't that be more protective? Well, it's important to remember that the AOC approach is not based on risk. The lookup tables are not risk-based, and they do not consider the toxicity of chemicals or the exposure time at all. In fact, the vast majority of our lookup tables are well below what is required for residential cleanup throughout the state of California. And removing soil that is not contaminated is not providing a measurable benefit to human health. And in fact, results in the habitat for our native plants, animals, and destruction of cultural resources. So always having more soil removed is not a good thing necessarily if it's not also providing significant extra protection of human health. Okay, so now we've gotten to the star of the show, maybe the proposed approach. I do really want to note that this is a proposal. We've not made any decisions. We have not decided that this is what we're going to do. This is just a proposal that we came up with to try to address these issues. So we worked really hard in developing an approach that stuck with one, of getting a cleanup to background. That is, of course, our goal, our requirements under the AOCs, that we will clean up these chemicals to background. So that remains our goal, but we needed to identify a way to reduce that false positive error rate. So the AOCs, as I noted previously, say that risk assessments will not be required. However, protection of human health is our mission here at DTSC. And so we do want to ensure that any changes to the proposal are indeed protective of human health. So the approach that we are considering does use risk assessment as a line of evidence. So again, this is a proposed approach. We've not made any decisions. In the next few slides, I'm going to be walking us through this approach. But I really want you to know that we want your feedback. There's going to be time at the end of this for us to have a Q&A and to discuss this, but it's not going to be the end of the discussion. We have our upcoming workshop on December 10th in Chatsworth. And at that meeting, we will be having an open house style, so you can come around and ask your questions. And then we'll also have a town hall for folks to ask questions. We're going to really continue to engage the community on this proposal and other potential proposals. So I'm just really uploading it up front because I think it's really important for you to know that this is not set in stone, but this is, what not me in a vacuum, but my team and those of us at DTSC have come up with to try to address this. And it is known, we're calling it the multiple lines of evidence approach. So what is meant by multiple lines of evidence? Basically, it means that we're using different types of proof to support an idea. So this approach makes an argument stronger and more reliable than relying on a single piece of information, just like being above or below a lookup table value. The use of multiple lines of evidence is considered a best practice by US EPA in environmental remediation. We feel much more confident in in how we are cleaning up sites if we're using multiple lines of evidence that are supporting our idea. Okay, so I'm going to, in a moment, walk us through all of our different lines of evidence that we're going to be considering if we have a sample on site that exceeds a lookup table value. First, before we get to that, I just want to talk about how we have 3 different categories for how we view these different lines of evidence. So I'm going to show a chart, so this will make a little bit more sense coming up. But green means that this is a supportive line of evidence. It supports that the sample is consistent with local background and no further soil removal would be needed in that area of that sample. Orange is a neutral line of evidence, and we should consider what the other lines of evidence are telling us. And red is telling us that that line of evidence does not pass our evaluation to be considered consistent with local background and that more soil removal is likely needed. Our current proposal is that if we have 3 supporting lines of evidence, then that would mean that the sample is consistent with local background levels. Okay, so let's get into these lines of evidence. So I understand, first off, you cannot probably see this chart that's on the left-hand side of this. And so I am going to walk you through each one of these, so you will be able to see them. But this flow chart outlines our 5 main lines of evidence. I know you see 1, 2, 3, 4. The first line of evidence really has 2 questions. And I'm going to walk you through each one of these. And really the goal of all of these questions is to help us determine when the soil cleanup at NASA and DOE is complete and consistent with local background. So the first line of evidence addresses the issues with the lookup table values that I discussed earlier. So there's 2 steps in this line of evidence. And the first step asks, is this detection consistent with local background? So we answer that first question by comparing any chemical that's detected above its lookup table value to the full range of detections from the chemical background reference study. So again, here we are at this scatter plot. Remember, each one of these dots represents a sample that was collected. The orange dots are non-detects, and the blue squares are detections. And the y-axis here represents the concentration in micrograms per kilogram. And so what we're proposing in this first line of evidence is that we would look at this whole data set. Because if we've got a detection that is above this lookup table value, but is below this other data, it would be consistent with local background. It's really a matter of how we chose to set that lookup table to aid us in site characterization that is making it say it's not consistent with local background. So in this line of evidence, we're considering that full range of data that we collected from the background data set. So in that, that's our first line of evidence. The second step within this first line of evidence, looking at the lookup tables, is asking about the method reporting limit. So is the method reporting limit for the MRL-based lookup table values reliably achievable? So to answer the second question, DTSC recently approved work plans from the responsible parties to evaluate current laboratory capabilities. Because it's really important that the MRL-based lookup table values are reliably met by the laboratories. And we do expect the results from that in late 2024, early 2025. We're already getting into late 2024, but we expect the results from that relatively soon. Okay, so that was the first line of evidence. So in the second line of evidence, we ask, is the chemical that was detected above its lookup table value, remember, if it's below its lookup table value, we are very confident that it is consistent with local background and we're not worried about it. But we're looking at lots of different chemicals within each individual sample location. So now, again, this is all on a sample by sample basis. So if there's a chemical above its lookup table value, is it that detection below the health protective screening level, assuming residential land use? So screening levels are chemical specific. So this would be specific to each chemical. There is a health protective screening level. These levels are considered safe for everyday exposure over a long period of time. And if we have a concentration that is below a screening level, it is considered very low risk. So in this scenario, if we have a lookup table value and it's detected our lookup table value is 2.4, and our detection is 2.5, but our health protective screening level is 1 million, then that 2.5 doesn't really make a big difference, and we're well below our health protective screening level. So that would be supporting line of evidence that we are consistent with local background. And this, so those first 2 lines of evidence, we're considering individual chemicals right within our sample. So let's consider this brown cylinder here to be a soil sample. And each of the different colored shapes inside represents a different chemical. So in the first 2 lines of evidence, we were looking at the individual chemicals and comparing them to the data in the lookup table or the residential screening level. But in lines of evidence 3 and 4, we are looking at all of the chemicals in the sample together. Okay. So In line of evidence 3, we are asking, is the cumulative risk below the DTSC point of departure for residential land use? So this means that we would calculate the risk and hazard associated with every chemical detection in a sample that has a lookup table, a detection above a lookup table value. And we look at them regardless if they are above a lookup table or not. We look at every detection, and we would calculate that cumulative risk. And we're going to be comparing that to the point of departure. The point of departure is when DTSC could normally depart from a site, and we wouldn't require further action there. So in most sites in California, this means unrestricted land use, and this is a residential scenario. So again, when we do a residential risk assessment, we are assuming this is a 26-year exposure, 350 days per year, that total of 7.5 cups of soil being ingested over that entire 26-year period. Remember, in a typical risk-based scenario, we're averaging soil concentrations over an entire exposure area, like the entire residential property. But for this background cleanup at Santa Susana, we are doing these evaluations on a sample by sample basis. So comparing the cumulative risk at a single sample is incredibly conservative, because this would be assuming that there is 7.5 cups of soil ingested at a single location over that 26-year period of time, which is well above a reasonable estimate. So in this line of evidence, if the cumulative risk is below the point of departure for residential use, that would be a supporting line of evidence that no soil removal is needed. Again, we understand that we are that we're using risk as a backstop. Maybe we have a chemical here or there that has a small increase over the lookup table, but we're well below risk-based levels. Then this is a backstop to tell us that we can consider this location may be appropriate for saying that it's cleaned up to background. And then finally, in the last line of evidence that we're proposing here tonight in this multiple lines of evidence is, again, we're looking at that cumulative risk and hazard from all of the chemical detections in the sample, whether they're above a lookup table or not. And we're asking if that risk is equal to or less than the risk associated with that same set of chemicals at the lookup table value. So let's explain that a little bit better. Hopefully this analogy helps. So this gray image here, can think of it as a scale. And so we're really weighing the difference between what we have in our sample, in our soil samples, our site samples, and what we have in the lookup tables. So let's say we have a sample that has 3 chemicals that are detected, chemicals A, B, and C. And we would calculate the risk of non-cancer hazard associated with those 3 chemicals. We would then use the lookup table values for those same 3 chemicals, and we would calculate what the associated risk and hazard is for that. And then we would compare the two. So here, this is showing them being equal, right? The scale is balanced, nothing is heavier. So now in this if the ratio is above 10, then that means that the sample has a higher risk associated with it than the lookup table values for that same set of chemicals. So again, same set of chemicals, A, B, C, at the detection within the site, and then at the lookup table value, we're balancing that. So in this example, this is not consistent with local background. We have a higher risk than is acceptable using our lookup table values. This is not appropriate. And so in this scenario, this sample would require additional soil removal. It is not consistent with local background. Now, in this scenario, if the ratio between the site sample, and the lookup tables is equal to or less than 1, so that's demonstrated here with the lookup table being heavier or leaning more towards that, the risk being higher in the lookup table values, then we would say that this is this is a supporting line of evidence, and this is consistent with local background because the risk associated with this sample location that has these 3 chemicals is lower than the risk at their acceptable lookup table values. So again, we're comparing the acceptable lookup table values, the background that represent our local background, and our current and the detections that we would have in our sample, and seeing how they line up. Okay, so to review these 5 lines of evidence, each of these asks a really important question. Line 1 asks, was the chemical detected in the background study? And if it was, is the detection consistent with local background? Again, looking at the full range of detections for that individual chemical within those 295 background soil samples. And then if the lookup table is based off of a method reporting limit, is that MRL reliably achievable using the data from the ongoing laboratory study? Line of evidence 2 asks, is the chemical that was detected above a lookup table below its health protective screening level, considering a residential land use? Lines 3 and 4 are looking at every detection within a sample, and it's asking, is the cumulative risk and hazard below the DTSC point of departure for residential land use? Now, I do really want to note, there are no plans to redevelop Santa Susana for residential land use. So this is very health protective. So it's not risk-based. It's not a true risk assessment. It's not a risk-based cleanup. It is just using risk as a backstop to really help us answer a question. And then finally, again, we're looking at the cumulative risk hazard for the site samples and comparing that to those same chemical detections, but using their lookup table values, which represent local background, to make sure that there's no increased risk due to what we see at the site versus what would be acceptable using our current lookup table values. Okay, so let's see how this works, because the whole point of this, right, was to develop an approach to take care of these false positive issues that we were seeing in our site samples, but really clearly in our background samples, which should pass our evaluation, given that they were the samples that we used to develop the lookup tables. They're the standard we are looking to achieve with this cleanup, right? So just to remind everybody, we collected a total of 295 samples from these 2 background reference locations, and the results from these samples were used to set those lookup table values. However, as I showed earlier in the presentation, 54% of those background reference areas failed the comparison to the 2013 lookup table values using the not to exceed approach. So we went and we applied the multiple lines of evidence approach that we have proposed here tonight to those background reference area soils. When we did that, all 295 soil samples were correctly identified as being consistent with local background levels. This is what we want to see, right? These are our local background levels. We need a test that appropriately identifies them as background, as being consistent with background. Otherwise, how will we ever know when we've achieved our goal at the Santa Susana Field Laboratory for NASA and DOE and these chemical soil cleanups to background? So again, we know that using the multiple lines of evidence on our background study samples, it shows us that yes, these are consistent with local background. And we also know that this remains protective of human health. This is above and beyond what we would even have for a residential, because again, this is on a sample by sample basis. There's no area averaging, but we know that this is protective of human health. And so we have some balancing criteria that allow us to deal with those false positives. Okay, let's see. And then, so what about on-site? As I said, this is just a proposal, so we haven't had we haven't really applied this a lot to the site because this is just a proposal. We're just trying to figure out if this is going to work, if this is something that the community can get behind, or if you have other suggestions of how we might potentially modify this approach or what other approaches we could take. Anyways, so we started this out by looking at applying it to the liquid oxygen area, which is in the NASA areas of and the NASA area. So what we did here is apply this to data that was collected at the NASA areas. And these were actually all step out samples from the initial contamination. So we don't have every single sample that's been collected in this area shown in this map. But what I want you to see, and what may be hard to see, so let me get my cursor over here. So this blue square here that I'm outlining, that is the source area. That is the LOX area there. And the key thing that I want you to see is that the green dots that are shown represent samples that pass the multiple lines of evidence approach. And the red samples are showing locations that would require remediation. There's more soil removal. There's soil removal needed there to clean up these sites and to clean up the contamination in this site. And what I really want you to note here is that the green is really in the perimeter of the source area and farther away up on this hill. These locations are actually up on a hill. You can actually kind of see the background image on this slide is actually from the LOX area. And you can see there's a hill area, and this area is on a very flat area. And so it's far away from the source area. We wouldn't expect it to be contaminated. So it's appropriate that those samples would pass. And so what this is really doing is showing us that our source areas are properly identified as being contaminated, and those are being cleaned up. That's not stopping. We're not leaving the contamination behind. But what the multiple lines of evidence does is it allows us to define the boundaries of contamination. And this results in a cleanup to background levels in the areas where the activities actually took place, but it also gives us an opportunity to limit those excessive false positives that would have us removing significantly more soil than is necessary while maintaining DTSC's mission of protecting human health and the environment. The multiple lines of evidence helps us define where to stop digging. And this is really important so that we don't unnecessarily destroy habitat without giving a measurable increased protection of human health. Okay, so you might be thinking, well, this MLE approach is just risk-based cleanup. No, it is not. This is still a cleanup to background. We are really putting a lot of emphasis on looking at that full background data set, on the actual achievable MRLs. We are just using risk as a tool to limit the unnecessary soil removal and destruction of habitat. It's a backstop. It's telling us where when we've achieved that background, but maybe we still have a couple of lookup tables here or there that are being exceeded, but we are well below anything that's going to cause a risk. It just allows us to know when to stop. Again, this evaluation is still done on a sample by sample basis. Every individual sample would be evaluated using this if a lookup table value is exceeded. There's no area averaging, so we're not going against what it says in the AOCs about not allowing area averaging. So in summary, the not to exceed approach identified in the AOCs frequently misidentifies soils as contaminated when they're not. Using this approach will lead to significant destruction of habitat, environment, and cultural resources. DTSC is proposing one potential solution to this issue, known as the multiple lines of evidence approach. The use of this approach limits the misidentification of soils as contaminated when they are not, and provides a clearer path towards our ultimate goal of achieving that cleanup to background. This method is more reliable and less destructive. Risk is used as a backstop to ensure that we are protective of human health while cleaning up the contamination and achieving a cleanup to local background levels. We are going to hold the responsible parties responsible for their contamination, but we need to know when to stop digging. So that's been a lot of technical information that I presented tonight. I do want to remind you that a video of this presentation will be available on our website. We have a dedicated page for our Soil Smarts Background Workshop Series, which you can access from the URL on the page or this QR code. We have developed a series of companion fact sheets and videos. We recommend that you start with the background on background video and you watch these in order. They are all numbered for convenience, 1 through 5, and you would finish with the unearthing a better approach. And so we really recommend that you spend some time with these materials. They present the information in a little bit of a different way, but also if there was a part of my presentation that you didn't quite understand and you want to see again, but you definitely don't want to go through the whole hour again, then we have these smaller videos. They range in length from about 2 to 10 minutes, depending on the topic. I also want to remind you that this is just our first workshop in the Soil Smarts workshop series. So right now we're here today at workshop number 1. Workshop number 2 is scheduled in person at our Chatsworth office on December 10th. This will be an open house style workshop where we will have stations set up covering each of the major topics discussed here today. So we'll be able to answer your questions, dig even deeper into these different topics, and you will have additional time to state your questions, concerns, or your potential solutions to move forward. In early 2025, we plan to have another workshop that will just be about discussing community feedback. We will be hearing from you and we'll be discussing with you. In a moment, Jamie is going to talk to you a little bit about a new comment tracker system that we have that will allow you to submit comments to us and track our responses to you. We're really excited about this tool. I'm excited for Jamie to tell you about it in a little bit. And so we encourage you to use that to communicate with us. Come to these upcoming workshops. Let's continue this dialogue. And of course, we have some time coming up for some Q&A. Just to point out the rest of our planned workshops in this series, I mentioned the laboratory study. When we get the results from that, we plan to have a workshop to present those results and discuss them with the community. There's also a backfill study going on looking for sources of backfill. And so we plan to have another workshop when we have the results from that study so we can talk about that more. And then we finally, a year from now, we plan to have a year recap where we really are bringing all of these things together, having more discussions. And we really are, Director Butler said we're moving into a phase of collaboration, and that's truly what we're doing here. We really do want to collaborate with you on finding the path forward, and this is just the first step, and this is just a proposal in getting us there. So with that, thank you for sticking with me through this really detailed and long presentation. This concludes what I have for you today, but I really am looking forward to your questions and just the ongoing dialogue as we move forward. And with that, I'm going to hand it back over to Fan for some closing thoughts before we get to our Q&A.
Yes, thank you, Dr. Hanley. That was very informative. And I just wanted, before we get to Q&A, just to do a little bit of a recap on what our guiding principles are going into this. We, DTSC, are 100% committed to holding the responsible parties accountable, to get to a cleanup to background, and to ensure that the contamination that they caused is removed from the site. But we also want to balance the cleanup with the interests of their biological and cultural resources. So protecting the natural ecosystem, protecting endangered, threatened species, and protecting cultural resources. And finally, we want to get to cleanup. We all want to get to cleanup. And so I hope that you also, the community, value these principles as we're moving forward. Having explained the technical issues with the background soils cleanup and explain one possible approach to address the challenges. The multiple lines of evidence approach is just one potential approach. It works as a checks and balances system to ensure cleanup values are consistent with background while also remaining protective of human health. If there's a different or additional lines of evidence to consider or other suggested approaches, we want to hear your suggestions. We understand that some of you may have questions or concerns regarding the potential approach presented today. We encourage you to provide feedback on our potential approach, or better yet, we welcome any suggestions or ideas that you may have to address the technical issues in light of the guiding principles. Again, we want this to be the start of a conversation to find a solution that gets us to cleanup. And with that, I'm going to turn it back over to Dr. Slaughter.
Thank you so much, Deputy Director Thanberg. We will now begin with the Q&A portion of this public workshop. As a reminder, this meeting is being recorded, and we ask that you please be courteous to all meeting attendees. And when providing your input or asking your questions verbally, please speak clearly and at an even pace. Each participant will have 2 minutes to ask your question. For the sake of time, please adhere to the 2 minutes. Manuel is on standby. We will have to mute participants at the 2-minute mark, and we will give you an opportunity to come back into line. And also we will let you know about how you can stay in touch with us to provide your questions if we don't get a chance to answer them tonight. You may also continue to type your questions or input into the Q&A section throughout the meeting. And again, please note that you may be muted if necessary. It is now 7:41. We will start a 1-hour Q&A until 8:41. So to participate, if you've joined by computer, please click the raise hand button or enter your input into the Q&A section. If you have called in from your phone, to mute or unmute yourself, please dial *6. To raise or lower your hand, please dial *9. When called on, please unmute yourself and ask your question or provide your input. And again, please limit your question or input to 2 minutes. You may rejoin the queue to ask additional questions. All right, Manuel, who is our first raised hand?
Thank you, Jamie. We have first Daniel Hirsch. If you can please unmute yourself. And I will give you a 30-second reminder when you have, you're almost completing your 2 minutes.
Can you hear me?
Yes.
Yes, we can.
Okay. I am absolutely blown away by your presentation. Every one of us, almost every one of us, predicted that you would try to break out of the AOCs that you signed in 2010 and break out of the requirement to clean up to background. In the EIR that you issued a year ago, you already exempted 2/3 of the DOE and NASA property from any cleanup at all. And now for the remaining third, you have decided to throw out the cleanup to background and put in this multiple line of evidence of fake stuff that violates the agreement and will leave the vast majority of the contamination not cleaned up. There was false statement after false statement after false statement just made in the last hour and 40 minutes. And I ask you to now schedule a similar 2-hour presentation where those of us who are critics of what you were doing can disclose to the public what you've said was false. Let me give a couple of examples. DTSC itself said at the time that the AOCs were signed that a cleanup to a risk-based standard would be equivalent to background because you have to use all of the land uses that Ventura County allows, which includes the rural residential, and DTSC's analysis showed that that would require a cleanup to background. Secondly, you went into closed-door negotiations with Boeing after promising you wouldn't do it. And then in those closed-door negotiations, you took Boeing's numbers and weakened the residential risk-based numbers by a factor of about 2,000. None of that is disclosed. You're all talking about the risk of false positives, which you are grossly misrepresenting. There's not a word about the risk of false negatives, of leaving the contamination there. DTSC is widely viewed as a captive agency, captive of the polluters that it is supposed to regulate. And tonight has been the absolute proof that is true. This claim that you want public input when you in fact have just decided that you're going to break the cleanup to background requirements, break the AOC, and leave the majority of the stuff there, you're acting as a surrogate for the polluters that you're supposed to be regulating. Every little bit of history of DTSC has now been proven correct. You are people who are the danger to the public rather than trying to protect them. I ask for an equal amount of an hour and 40 minutes that you put on with the critics so the public can hear the truth.
Thank you, Mr. Hirsch. Thank you, Manuel. Who is our next person with raised hand?
We next have Olivia Dietrich.
Olivia Diedrich, can you please unmute yourself and ask your question or input?
Hello. Despite what representatives conveyed during tonight's presentation, I do not trust that the DTSC will fulfill its duty to the public to enforce a cleanup of the Santa Susana Field Lab to background levels by the responsible polluters in question. DTSC already broke its promises to enforce its 2007 and 2010 cleanup agreements in 2022 when it bypassed public comment and entered into a clandestine deal with Boeing that decimated Boeing's cleanup responsibilities. Then in 2023, DTSC released its final environmental impact report, and DOE and NASA claimed exemptions to worm their way out of about 2/3 of their designated cleanup areas. The DTSC is now lowering cleanup standards for these polluters even further by suggesting to weaken labs measurements minimum reporting levels that were laid out in DTSC's lookup table. Furthermore, DTSC continues to propagate DOE and NASA's false claim that they cannot locate enough clean soil to backfill. These excuses fail to justify DTSC's prolonged continued allowance for polluters to flout its cleanup standards, while the neighboring community members continue suffering the tangible ramifications of their pollution. As a member of the public, I do not feel adequately protected by the DTSC from polluters given DTSC's history of repeatedly pandering to polluters rather than putting its foot down for the surrounding community safety.
30 seconds left.
You have 30 seconds. You can keep going.
I'll yield my time.
Okay, thank you so much. There wasn't a question there. No one wants to address anything. We can continue on. Manuel, who is our next person?
I'm sorry. Can I just real quickly, Jamie? I do want to just address that we presented facts here tonight. Everything that I presented is a true statement. We showed you the data. We're here showing you real information. I wasn't here when any of these AOCs were signed, but I'm here now. And my goal and my mission is to protect the people of California. I know that's our mission, so maybe it sounds like it's not a real thing, but truthfully, that is my goal. And I'm a human health toxicologist. I'm a senior toxicologist at the Human Ecological Risk Office. I absolutely care about protecting human health. And this is a cleanup to background, and it is not breaking the AOCs. And we've been here telling you the truth tonight. And I just wanted to state that because I am not up here lying, and I do not want to sit here and let that be stated when it is not true. Thank you, Jamie.
Thank you, Dr. Hanley. Manuel, who is our third person? We're going to take 5 raised hands, and then we're going to move to the Q&A.
Next in line, we have Chris Rowe.
Chris, you can unmute yourself.
Hi, I want to thank you, and I want to state that I really appreciated the approach of Dr. Henley in everything that was presented tonight. I absolutely was thrilled to see this, that it supports. I put in a lot of comments. You have to have split samples to do quality control. And I'm looking at my own home, which is within 3 to 4 miles of the site, and finding radon in my own home, and which indicates the potential presence for things like thorium and uranium in the ground below my home. And so we cannot possibly attribute all the illnesses that are in our community to the Santa Susana Field Lab. I'm not from California, although I've lived in West Hills for 46 plus years, at this distance from the site. My family members have had cancer and other illnesses, and they were not here. So what I'm saying to you is there are many, many things, so many things in our environment. DTSC has its departments like Safer Cosmetics and other things, and we are not considering the fact that people are being exposed to things like fireworks. We have other fires that have occurred in the community where flame retardants are dropped, and and the chemicals from the fire spread besides the Woolsey fire. Fukushima occurred after we did our EPA background studies. I've been involved with this site since 2006. So I've been at these lookup table meetings, and I think this was.
Thank you so much, Ms. Rowe. Manuel, who is our fourth person?
Next person we have in line is Christina Walsh.
Thank you, Christina.
Yes, hi, thank you. I actually would like to ask questions about this AOC that you have described. I understand the need or desire to say that everything that has been stated tonight is true. However, the AOC has exceptions. It requires that those exceptions are adhered to, including protected threatened species, as well as traditional cultural property designations. So to make an estimate of soil movement and damage on the basis of what if we didn't have to follow any of the rules and only had to just remove the maximum amount, which is not what is required and which is not part of the law, and indeed which is not part of the AOC. And everyone who has made presentations is well aware of that. So what is the amount of soil? And by the way, also, Boeing did a risk assessment on their portion, which is biochemical and radionuclide. So you have the information you need in order to make responsible decisions and not needlessly remove soil that isn't toxic. So this circular game for literally decades, I was on that background study. I walked every inch of that with that group of people, but people like me are silenced, like now.
Thank
You
you.
still have 30 seconds.
Okay. You have 30 seconds left, Christina, if you want to continue.
Well, I would like you to provide an estimate instead of the 4 million yards, because after all of this was sampled, we were given numbers like 800,000 cubic yards, and now it's 4 million. And I feel like this is another deflection to make people just not want to do it. And I would.
Thank you, Ms. Walsh. Okay, we'll take one more person and then we'll go to the Q&A. Manuel, who's our next person?
Next we have Melissa Bumstead.
Thank you. Melissa.
Hi. I had a question. I'm not happy with this presentation. I do not believe that it is in the best interest of the community. And as a mom myself, and my daughter's a 2-time cancer survivor, knowing that there are 80 children in our community who've been recently diagnosed with cancer, this is not a sufficient cleanup. I have a few issues, but the one I'm going to focus on right now is to do with childhood cancer. UC Berkeley study looking at leukemia and its 30% increase in childhood cancer rates since the 1970s. They assumed that children ingest 100 milligrams of dirt a day. So I did the math real quick, and that means in about 4 years, a child would be ingesting 6 cups of soil, approximately. The study that was done is saying that would be over 32 years. So I'm wondering, was that assumption done with 100% residential garden?
Thank you, Melissa. Valerie, would you like to take that?
No, it was not done with the 100% garden because that is not our standard residential cleanup approach. I don't know what to tell you about your math. I did do it. I agree with you. It is 200 milligrams per day that children are that we assume for risk assessment. And then for adults, it's 100 milligrams per day. For children, they're only assumed to be children. I know this seems weird. I'm a mom. Obviously, they're children a lot longer than 6 years, but that's how we do it in risk assessment. I do just want to also note, I wanted to answer your question, but I hear you. I hope that your daughter is doing well. I'm sorry for all of the cancers in your community. My best friend when I was 9 died of leukemia. I understand. I don't understand. I'm not a mom with a child with cancer. So I don't understand. But I do want to tell you that I feel for what the community has gone through, and I understand your frustration. But I am here today as a scientist and a human and a mom, just giving you the facts and what I've evaluated. And I think that's all I can offer at this point. But thank you.
May I have a few seconds more, because part of that was part of the answer and not just my question? Would that be acceptable?
Yes, you didn't go over your 2 minutes. Go ahead.
Okay, thank you. One of my concerns with this looking at risk-based assumptions is that this is talking about how the risk, this is what NASA said back in 2018, where they showed option A and option C, and that there was no difference between the health risks of them cleaning up almost none of the site and almost all of the site. And they assumed that it would not change any risk to human health, because that was based on the assumption that people weren't living right next to the site. And so again, when this is talking about looking at risk-based cleanup, the DTSC has always told us that contamination isn't coming off site in levels that can harm human health, even though we have data and studies that the DTSC has not accepted, that independent federally funded studies that shows that it actually is.
5 seconds.
In your risk assessment here, are you considering the people living on site, or are you considering only the hypothetical people that would live near the site compared to hypothetical people living on the site? Or it just opens the whole door to do what going there.
But yeah, no, I think I understand your question, and I hear what you're saying. So it's not a risk assessment. I just do want to say that. I know we're using risk, and I know it seems like a risk assessment, but it really isn't. But how this evaluation would be assuming that people are actually living on the site, which they're not. And by doing that, that would be protective of people that are off the site, because anything leaving the site would be reduced. If you're worried about dust leaving the site, that's going to be diluted as it leaves the site. It's dispersed in the air. I mean, we have air monitoring, so we know, we don't have concerns that what's leaving the site and dust is unhealthy. But what we're looking at is a sample by sample. So typically when we'd be doing a risk assessment, we'd look at an entire residential area. So over a 1/4 acre of area, and we'd collect all kinds of samples, and we'd average that data together. And then we'd come up with one number, and we'd use that number to do a risk assessment. And we'd compare that to a health protective value. In this approach, we're still doing the sample by sample approach of the AOCs. But we're looking at every single sample. Every single sample is being evaluated that way. There are not 7.5 cups in, the amount of soil, surface soil. I don't know. I'll be honest. I don't know to what depth of soil sample you would get 7.5 cups, but there aren't 7.5 cups at that concentration in each of those samples for someone to be exposed to. So it's incredibly health protective. Even if someone was living on the site, it's incredibly health protective, but even more so for anyone who's living off the site. So this very much is thinking of the community, is protecting the community. So I don't want to take any more time. I want people to answer questions, but I'm happy to speak to you more about this.
Thank you, Valerie. And now we're going to go to the Q&A. Bill, what is our first question in the Q&A, please?
Yes, thank you, Jamie. We have a few questions from Ms. Bonnie Hughes, and they're related. And Bonnie, I apologize. Some of these were probably very specific to a slide. So if I don't have the full context, feel free to chime in and let me know what slide or what comment that DTSC made that you're specifically responding to. The first one is, why did they skew the results? And I'm not certain exactly what that's regarding, but I know that we did throw up a slide earlier that showed statistics and some graphs. I think it was relating to MRLs. Bonnie, if I'm incorrect, please correct me.
I think I might know exactly what Bonnie is referring to, if I may, Bill. So when I was talking about the outliers in those background threshold value-based lookup table values, we talked about how we remove statistical outliers. So the way they skew the results is when you calculate a background threshold value, it's a statistical evaluation of an upper limit. This gets pretty, scientific. But if you have higher concentrations that are there, then that's going to make that lookup table go higher. And so by removing the outlier data, it means that we ended up with lower lookup table values. If we did not remove those statistical outliers from the data set, those lookup table values would have been set at a higher value because that BTV would be higher because those higher concentrations would have been considered in making that statistical estimate of background. So I hope that helps.
Thank you. Bill, you're on mute.
Apologize for that. Thank you for that, Valerie. And again, Bonnie, if that wasn't what your question was in regards to, please feel free to chime in either in the chat or you can raise your hand and we can call on you verbally. The next question actually also comes from Bonnie, and this was probably answered. It's just asking about the outliers. That's the question. There's not a little more details on that because again, it was contextual, but I believe it's to the same topic about the results.
Bonnie, please correct me if I'm wrong, but I'm hoping that the answer that I just gave, I saw both of your questions, so I kind of assumed they went together. So hopefully I answered that, but if not, as Bill said, please let us know and we can answer it.
All right, thank you very much. The next question comes from Kit Stultz, and Valerie, this is directed towards you and to other members of the team. And Kit says, it appears that from this presentation that Ms. Hanley and her team have developed a substantially different approach for NASA and DOE cleanups from the past methods of the AOCs. Can you talk a bit about how long her team has been on this task, what sort of commitment it required from DTSC, and if her team has been tasked with other possible SSFL objectives? And it was a multi-part question. If you want me to reread any of that, please let me know.
Valerie or Steve, would you like to take that?
I think I saw Steve was going to answer. I will just say I don't have a team necessarily. I'm a toxicologist, but I don't have a team of folks. But we've been looking at possible solutions for AOC implementation really since the PEIR has been signed, really before that, because we knew that we were now going to be able to move to cleanup. We were going to be able to get to decision documents, and we needed to find a way to move forward. And so, we've been working on it since then, so we can really move forward. But I'll let Steve answer if he has something additional he wanted to add, or if there's something else that I can clarify. I work on Santa Susana for all three RPs. I am a human health risk assessor, so anything associated with risk, I also work on. So, I'm not sure how else to answer that question.
Thanks, Valerie. I can answer that question in a little bit more detail. So, over the course of time, it has been identified and made known that there were concerns over potentially finding enough clean backfill, as well as being able to achieve certain method reporting limits. So those are things that have been acknowledged kind of in the long course of time. And then more recently, with the certification of the PEIR and getting into more of the cleanup plans, we started delving into the aspect of implementation and some of the technical issues that the AOC posed. So that's probably been maybe about a year to year and a half that we've been, delving into that effort. And so hopefully that helps clarify a little bit.
Thank you, Steve. Bill, what's the next Q&A that we have?
Yes, so this next one comes from an anonymous attendee, and it's a bit technical. And so, Valerie, you might be the best to answer this, but why are you using single value tables as background levels rather than modeling the background levels using another method like Bayesian mixed effects that would allow for predictive background measure to compare to based on various sampling parameters? It seems like this would help prevent the high rate of false positives in the test that you use, especially since levels of chemicals vary so widely across the sampling scheme. I think the term false positive and misidentification seems misleading when your original background levels that you are comparing to are poorly defined. Again, there's a lot of information in that one. So if you'd like me to reread any portion, please let me know.
Okay, thanks, Bill. I've got it here. Yeah, I think that is an excellent suggestion. I will say that there were decisions made on how to set the lookup tables long before I was associated with this site. They set the lookup table values again in a way to help aid in site characterization. And it was always known that there would need to be some adjustment moving forward. I think your suggestion of using modeling and using Bayesian and looking at Bayesian mixed effects, is a great idea, and one that I would encourage you to continue to submit as we talk about this. That first line of evidence is looking at that background data set and really thinking about how we can use that full range of data that we collected in that background data set to say if a sample is consistent with local background. Because we know that right now our lookup table values are not properly answering that question. And so we need to be able to look at that full range of data to be able to answer it. So something like that is certainly something that you could submit as something for us to consider. That's really what this process is about. We want this kind of feedback from folks so we can talk about it. And I would agree, we're calling the background data false positives in a way to just try to explain how they would be false positives on site. I know doesn't really make a whole lot of sense to use the data that was used to set the lookup tables to evaluate the lookup tables, but I think for illustration purposes, I think it's very helpful to see that there are real issues with the current approach. And so that's why we explained it in that way. But thank you for your comment and suggestion.
Also wanted to say we're really open to suggestions on how to look at background with other more sophisticated statistical approaches. So, that's one of the reasons why we're here tonight. We're here to solicit input and start that dialogue. So we are certainly all ears and open to that. So thank you for the suggestion. I just wanted to add that.
Thank you. And we're going to go back to raised hands momentarily. Bill, Manuel, who is our next person with raised hands? Thank you, Bill.
Thank you, Jamie. The next person we have is Julie Korenstein.
Julie, please ask your question.
Hi, yes. I'm going to go ahead and ask a few questions and then I'll wait for the answers, if I could, please. I needed to know the difference between local background levels and residential level. And also, if there is 54% false positives, why is it going to take 15 years to clean up? The original consent decree, 2010, I think it was supposed to be completed by 2017. I believe with the 15 years from now, it's 2039 until it's completed. I have a great-grandson who lives in Simi Valley. He's 1 year old. He'll be 16 years old by then. The question was already answered about will homes be built in the area? And I believe, was it Valerie? I'm not sure who said no development at this site, which I've never heard of before. That is quite interesting. Lastly, I believe the discussion tonight was about chemicals. What about the radionuclides? Is that a different discussion? I don't believe it was included.
Thank you, Julie. Valerie, Julie had 4 questions. Do you need me to recap anything or would you like to take them?
I will at least answer some of her questions and maybe some of the other team, or maybe I'll ask you the first question of hers that I wanted to address is you asked what the difference was between correct me if I'm wrong, Jamie, but I think she asked what the difference is between a background level and a residential level. Is that correct?
Yes, and including local background. Yeah.
Yeah. Okay. So local background is, we established that by looking at these 2 different sites. All soils have chemicals present in them, whether it's from naturally decaying rocks that are in the soil, or it's from aerial deposition of different things. We have chemicals in our soil. That's just how soil works. And so local background, that's why we picked these two locations that were not far from Santa Susana. They're local to Santa Susana. And we evaluated what was there. Now, when I talk about residential levels, I'm talking about a risk-based residential level. So these are screening levels that are developed by DTSC and US EPA. US EPA has screening levels. DTSC often uses their screening levels. We have some that are slightly different as well, but those use risk. So those assume that land would be used as residential, that someone would be living there for 26 years, that they 350 days a year, that they would have all of this soil exposure during that time. And so then that's a risk-based value. And it considers the toxicity of the chemical. Every chemical has a different toxicity associated with it. And so risk assessment considers all of those things. So a residential screening level is calculated based off of all of these things, and it considers the point of departure. Like I said, DTSC has levels that we could walk away from and say that this could be used for residential properties. The local background levels are typically much lower than what we would have for a residential cleanup. So hopefully I answered that part of the question. Jamie, maybe you can remind me. I know there was a question about delays, and I think that
I can take
Steve
that.
Can speak to that. Yeah.
I can take that. I'll give you a breather. So I do understand, that it is perceived there has been delays, but just to kind of go over the chronology a little bit, in 2010, DTSC entered into the AOC agreements with NASA and DOE. And following that, a background study and lookup tables were developed between 2010 and 2013. And then additional soil investigation was conducted from 2011 to 2017. It's also important to understand that there has been cleanup going on the site. DTSC has issued multiple interim cleanup orders. There's 2 cleanups that are underway now and almost complete at the Area 1 burn pit and the shooting range. And also to date, about 15 interim soil cleanups have been completed. And then in 2023, the PEIR, which is a key document, was certified, which allows cleanup planning and implementation to begin to move forward. It is important to understand there is a lot of planning that has to go into getting these plans developed, prepared, out for public comment, reviewed, approved. So it doesn't happen overnight, but we're moving as expeditiously as possible. And we want to make sure the community has their input on those cleanup plans. So I just want to emphasize DTSC is working diligently to move the process forward while ensuring that it's done correctly.
Thank you, Steve. And her other 2 questions were about information about no homes being developed on the site, as well as why we are discussing chemicals and not radionuclides, and when and how will radionuclides be addressed.
I wanted to address the radionuclides. So radionuclides will be cleaned up to background on the site, as will the chemicals. We didn't talk about radionuclides today because they don't share this same issue. One of the reasons why we have such a high false positive error rate is because there are so many chemicals in the chemical lookup table. There are many fewer radionuclides on that lookup table. And so because of that, we don't have that compounding false positive error rate as much. That's one of the reasons. And so because of that, they don't share the same issues. So we're not proposing that the multiple lines of evidence approach would be applied to radionuclides. And just for clarity, I said there's no current plans for the site to be developed for residential. I don't think that we don't have current land use controls in place that would prevent those from happening, but there is no plans. I think that the real desired use for the site is for it to be open space for our, native plants and animals and the protective species and other things, and for hikers and other activities. But I'll just stop saying that. But what I really want to say is there's no planned use at this time for any residential development.
Thank you, Valerie. And Julie, you had 47 seconds left. Do you have any clarifying questions, or are you okay with the responses that you were provided with?
Yeah. Well, I'm a lay person, so some of these things are very complicated for me, and I'm trying my best to understand it. But I kind of got a double answer. Valerie, I thank you very much for your information. But as far as homes being built in that area, that there isn't anything right at this moment, but in 5 or 10 or well, it would have to be after the cleanup, I guess. Let's say 20 years from now. Will homes be built on that? And what is the impact on children and pets and people that like to grow vegetables in their backyard and eat it and so forth? How I don't know that I don't feel like there's any guarantee that that particular site will never be used again for homes and for little children, because I worry about my family, my great grandson. I worry about all the children that have already been impacted with terrible cancers. That's all. Thank you so much.
Thank you, Julie. Manuel, who is our next person? Unless Valerie, you have something to add?
I just wanted to say that, Julie, I hope that you'll come. I hope you're able to come to our in-person workshop on December 10th, because I think that's where we're really going to be able to have some of these more one-on-one conversations and be able to get some more of your questions answered. So I do hope you're able to come and we can continue the dialogue.
Thank you, Julie. Thank you, Valerie. Manuel, who is our next person with raised hand?
Next person we have in line is PJD.
Hi, thanks so much. This is my first time here, and I am very new to the area. So thank you all for your time, and thank you for the robust questions from the community. I've only been here for a short amount of time and moved from Woodland Hills. I had never heard of this before, so I was concerned. Is it safe to have my family here playing outside, drinking the water? And at our old house in Woodland Hills, it's not too far from where we are now, but I'm concerned because we started having some adverse health effects, and we discovered that we were getting a lot of air that was of poor quality from the soil beneath us blowing up through our AC vents. So we're trying to figure out why. Is DTSC saying that this area, West Hills, Woodland Hills, Calabasas, this is all perfectly safe? People shouldn't worry about this Santa Susana Field issue, and that it's perfectly safe to live here?
Thank you, Valerie.
Well, I would say that Santa Susana is certainly not the only property that is around. And I don't think that anyone can ever with any certainty say that everything is safe. I think I would be incorrectly stating something if I said that. What I will say is that we do not believe that the Santa Susana Field Laboratory is contaminating your soils in the neighborhood that you live, and that would be responsible for your inhalation, your issues you're having. I'm sorry that you're having that concern with your AC and your dust, and especially having just moved, that's got to be really challenging. I would say
we moved from Woodland Hills to here to West Hills because we thought it was actually safer because the homes were newer and they were on a slab. So the ironic part is that we might have unknowingly for 4 or 5 years been exposed to something. And if Valerie, if you say that you would move your family to West Hills or Woodland Hills and you wouldn't be worried about any kind of residue, you seem very trustworthy and knowledgeable. And if you say that you would be happy to have raising I think you said you have 4 kids.
I do.
So if you think it's safe that your kids can live and play and be in this community that I just moved to, I would take you at your word on it, and I appreciate your help. And if you can tell me what the 5 chemicals were that were over the limit, I'm curious, but I just am looking for more answers because, again, this is very, very new to me.
Yeah, I can look them up. I know that they were arsenic. Arsenic is always above risk-based levels. It's just very common. It's very common in the Earth's crust. I believe that, I don't want to tell you the wrong answer and I don't have it right in front of me, but I could certainly follow up and tell you what they were. But they were all metals that are naturally occurring in soil. And I would say, we do have DTSC staff that lives in Woodland Hills with their families. I wouldn't have any issue moving to Woodland Hills, except for that I'm a Northern California girl. But other than that, I don't think I wouldn't have any concerns that living in the neighborhood surrounding Santa Susana that my children would be at risk because of the site that's there. I feel confident in saying that to you. So I hope that you continue to have good health.
Thank you. So just in closing on that, would you say that West Hills also safe, Woodland Hills safe, and you would be comfortable moving there and having your family raised in West Hills, we're right below Bell Canyon now. So I see on the map, the Santa Susana Field Lab or this Rocketdyne facility appears to literally be right over the hill from where we moved to.
Yeah.
Which again, I'm from New York, so this is quite surprising. And
Yeah.
we have other problems, big rats. But
Yeah.
but here, I had no idea there was a gigantic, field that might have possible contaminants and runoff. So are you saying that you feel that it's safe to move your family as well to this neighborhood, like right below Bell Canyon? It looks like where's the Boeing zone?
Yeah, I mean, I think the DTSC monitors the air. We monitor the groundwater. Along with the water board, and I feel confident that we don't have contamination leaving this site in levels that are going to cause harm. I'll say we live in an industrialized world with lots of different exposures to lots of different chemicals. And Southern California is certainly not alone in that. And so I think anywhere that we are, there are dangers and there's risks associated with it. But I wouldn't be concerned to go and live there based off of being that close to the Santa Susana Field Laboratory. Personally,
Sure. Would you be concerned for some other reason that you know of that's not the Santa Susana Field Laboratory?
I don't, no, I wouldn't. I don't have any secret hidden thing in the back that I'm
wondering if there's something else I don't know about in the area.
I mean, I don't know everything about Woodland Hills, but no, I would say no.
Well, it's just really, I'm now in West Hills now, so who knows? But the last question I have for you and I appreciate you going through the methodology that you guys use. And again, I'm new. I don't know if you thought about it before. Has anybody looked to use either the problematic risk assessment like a PRA and using the Monte Carlo simulations to account for like variability and uncertainty in the exposure scenarios, or dose response models, or integrated risk information systems to combine toxicity data with the site-specific exposure assessment for a comprehensive risk evaluation, and maybe even looking to see whatever these 5 chemicals are? And I know you said you don't remember what they are.
You have 10 seconds.
But maybe how they've combined with other levels of nitrates or other things that are in the soil and the air. But those risk assessments might be better. I put them into the chat for you guys to consider. It might be helpful.
Yeah, no, well, for NASA and DOE, we are not considering those kinds of risk assessments because we're doing a cleanup to background for NASA and DOE. And so, I think you've named a lot of really wonderful ways that we do risk assessment. There have been Monte Carlo simulations done to look at the false positive issues. And so we have done some of this probabilistic risk assessment. But this is a cleanup to background. We're just using risk as a tool. The proposal is to use risk as a backstop here. But for this site, we're not doing that. The Boeing area is a risk-based cleanup, and that's not the purpose of this particular workshop series. But we can certainly give you more information about what's being done at Boeing. But this is a cleanup to background, and so we're not using any of those more. I don't want to use the word fancy, but kind of some of those more fancy mathematical programs and risk assessments are not on the table for the NASA and DOE areas.
Thank you, Valerie. We have 20 minutes left in our Q&A session. There is our stream website at the bottom, is the URL at the bottom of the screen. Please take note of that. We will go into more detail coming up in the next couple of slides. Manuel, who is our next person with raised hand, please?
Next, we have Michaela Partington.
Thank you.
What is being done to ensure that the AOC is cleaned up and the background levels will be actually cleaned up? From the presentation that I heard, it seems like you guys are backtracking in your effort to clean up to background. We need to clean up Santa Susana to background. I am greatly concerned about all the contaminants and the communities that it is spreading off-site. To say it is not is absurd. And I am what is being done to ensure that the LUT is not going to be redone?
Thank you, Michaela. Steve or Valerie, would you like to take that one?
I just want to again say we are doing a cleanup to background. We are, per the AOC, this is a cleanup to background. We are having to make some adjustments to the methodology that's outlined in the AOCs, but this is still a cleanup to background. We're not trying to back out of it. We are committed to a cleanup to background for soils. We monitor dust that's leaving the property. We monitor groundwater. So we feel very comfortable in what we're saying. Your health is important to us. It truly is. This is our goal. This is our mission. And I know it sounds cheesy to say a mission statement, but it's true. That's our mission. And we are sticking to our commitment to do a cleanup to background. And that's what we're doing here for the site. Thanks for your question.
Quick question at the end, Michaela, were you asking about if we are changing the lookup table values? Is that what you were referencing, the LUTs?
Yes, because
Okay.
I'm deeply concerned that will be changed.
Sure. At this point, DTSC is not proposing any changes to the lookup table values. We're simply looking at the multiple lines of evidence at this point and trying to roll that out for public discussion and input.
Thank you, Steve. Michaela, you still have 1 minute and 24 seconds. Did you have anything else you wanted to ask?
What can be done to ensure that the cleanup is actually done in a timely manner and that all the contaminants is cleaned up? Because so many people are continuing to have health effects from Santa Susana and offsite contamination. And I'm also concerned that there's no protections in place to ensure that no homes go up on the site during the cleanup and after the cleanup.
Thank you.
Can speak to the first part of your question and probably the second part as well. So with regard to the, people, so I'm sorry, I just lost my train of thought. Can you repeat your first question again? I apologize.
What can be done to ensure that the full cleanup is actually done in a timely manner, as so many residents are continuing to have health effects from the contamination that is going off-site?
So, as I identified earlier, we're now at the point where with the PEIR certified, we are able to start moving forward with the decision documents, and we are currently posting to our website the schedule for when we believe the public input or public comment periods will be held for those. So we are really starting to ramp up. We are starting to receive draft documents, and the reason we're having this discussion tonight is to allow, to come up with a solution to allow the background cleanup to be implementable. So that's number one. And so, Boeing has their cleanup, but then you've got Department of Energy and NASA. And so that's why we're here tonight, to try and help advance the discussions on that and get to a point where they can submit a cleanup document that will provide a background cleanup. As far as homes not being built, at this point, there are some things recorded against the property that would prevent that. And DTSC will need to look at, where the final cleanup ends up, and if any areas need to have certain restrictions applied to them. That is a possibility, especially if possibly in some of the exception areas, if they're granted. So, and those are granted on a case-by-case basis and evaluated independently. So hopefully that helps answer your question. But at this point, there are no plans. I understand there's a lot of concern and public concern about future homes being built, but at this point, there are things recorded against the property that would theoretically prevent that from happening.
Thank you, Steve. Okay, Manuel, who is the next person with raised hands, please?
Next person we have is Hakon Williams.
Hi, can you hear me?
Yes.
Great. Well, I'm sitting here at a loss. You guys are smooth. Yeah, it's probably the biggest lie we've heard tonight is that everything we've heard from DTSC is factual. Just one small example. There have been a number of misrepresentations, to say the least, tonight, but Yeah, in tonight's presentation, the lookup tables were called provisional. The DTSC 2013 memo producing those lookup tables specifically stated that the chemical lookup table is not provisional. That's a small example, but it's exactly the kind of misrepresentation, blatant misrepresentation and lying that we've come to expect from DTSC. We've sat here listening to DTSC conduct, an over hour-long attack on its own agreement that it's supposed to be implementing. Everything about tonight's presentation was to make you, in the public, think that the current cleanup agreement is in fact too good. Good folks at DTSC love to wave their credentials around. I think what they're actually expert at is manufacturing consent, getting us to want them to contamination on site, like leading lambs to slaughter. Others have talked about this long history of DTSC's, not deserving the trust of the community, multiple betrayals.
30 seconds left.
Yeah, we've just heard a bunch of old DTSC narratives trotted out again tonight that have long been debunked, that the cleanup's going to moonscape the site. There'll be 96 trucks a day for 15 years. The entire site is, it's, the propaganda couldn't be clearer. It's very clear what's actually being proposed. DTSC wants to allow DOE and NASA to violate the legally binding SSFL cleanup agreements and abandon the cleanup to background. I want to second the request earlier.
Thank you. Steve, did you want to respond?
I just want to say, we're actually here tonight to start the dialogue with the community and to roll out, one potential concept. We are not married to that concept. If there are other proposals that will work, that will help allow us to overcome the technical issues that we've identified associated with the AOCs, we are more than happy to entertain those, and we welcome any input, criticism of things, suggestions, etc. But to state that, it's just that's what we're here for. So I'm sorry you walked away with a misinterpretation, Mr. Williams, but that's what we're here for tonight.
Thank you, Steve. Manuel, who is our next person with raised hands?
Next, we have Hannah Dye.
Hannah, would you please
Hello.
unmute yourself?
Can you hear me?
Yes.
Okay, great. I am an early career toxicologist, so I appreciate what you guys are trying to do. But one thing that I've noticed in my experience is that the risk assessment side of toxicology takes a very different approach than a lot of the other disciplines that are kind of adjacent to the toxicology field. So I guess my question is, who is on this team that is kind of making these adjustments? Like, what are their backgrounds? What are their expertise? Is it just toxicologists at DTSC, or are there biostatisticians that are involved, or who else is involved in this process? Any epidemiologists?
Valerie, would you like to take that one?
DTSC does not have epidemiologists on staff. We have various backgrounds. I myself am a toxicologist. I have a PhD in pathology and did a postdoc in respiratory toxicology, and biochemistry, molecular biology is my undergrad. We've got geologists, we've got engineers, we've got folks with lots of different backgrounds who are looking at this. I'm not sure if that answers your question, but we do not have epidemiologists on staff, no. And really, this is not risk assessment. It's not. As a toxicologist, I hope you recognize that this isn't risk assessment. We're doing a cleanup to background, and we're using risk as a backstop. We're using it as a line of evidence, but this isn't a risk assessment. So that's not what we're doing here. We're doing a cleanup to background.
Mm-hmm. And if you're cleaning up to background and trying to use, I feel like my big question is, do you have biostatisticians on your team, or is it just the toxicologist? Because that's kind of, I don't know, I feel like the cross-disciplinary work there is really, really important, and it seems to be lacking.
Our toxicologists do. I mean, I have a fair level of statistical background. I definitely have taken a number of biostatistics classes, and I have a colleague who's also quite good at statistics. And so I wouldn't call myself a statistician by any means. I will say that when the lookup tables were established, we did follow the guidance of a statistician who made recommendations to US EPA for their radiological lookup table values, and we use that same method moving forward. Oh yes, Director Butler, please go ahead.
Thank you. Yeah, hi Hannah. I'm Katie. I'm the director of DTSC. My master's in public health was actually in epidemiology, so I love that you asked this question. And I agree that some interdisciplinary work with biostatisticians could really be an add to this project. So I think we should take that back and, just make sure we're maximizing the expertise we do have across the department. We have a number of biostatisticians in our department and statisticians. So thank you for that suggestion.
I know, especially when you're communicating with the community members, I think that there was a lot of misleading representations of the statistics that you guys are presenting. I think it is all very factual, but I think the way that you're representing it, it would have been helpful to have a biostatistician help you with the communication to the community.
Thank you. Yeah, great suggestion.
The other quick question, if I have time, I was curious have you guys considered any in situ cleanup efforts? Why is there such a focus on this one full removal of the soil? Is there any documentation on the other treatment methods that you considered?
Valerie, would you like to take that one?
I'm going to go with that being a better question for somebody else on the team. Steve, would you like to take it?
Yeah, I can speak to that a little bit. So, there are in situ technologies that have been considered, for things like volatile organic compounds, using SVE. They're looking into, ways to treat groundwater in situ. So in situ technologies are being looked at, but unfortunately in some areas, the mix of contaminants isn't conducive to just one treatment technology. It would require multiple treatment technologies. So you would have to maybe treat some of it in place, then excavate it, treat it further. It just isn't cost effective to conduct many of the areas of cleanup. That's obviously the first alternative we like to see used if we can, but in many cases, the excavation and disposal is going to be the preferred method just because of the mix of contaminants that are present. So hopefully that helps.
Thank you, Steve. And we are going to go to the Q&A next. We have about a couple of minutes left in this public workshop. But before we do a question, I do see that we did not completely respond to the provisional lookup table question that Michaela had. Valerie, would you like to address that before we take a question from Bill?
Yeah, sure. I just wanted to note that we did talk about the provisional lookup tables in the PEIR. They were referred to as provisional at that time. You're correct that there is a line in the lookup table tech memo that says that the multi-lab MRLs are not considered to be provisional because we felt that they were strong. I say we, I wasn't here at the time, but so that line is in there specifically about the multi-lab MRLs, but it's not about every single one that is in there. And we noted in the PEIR that we needed to check laboratory capabilities and make sure that our BTVs were accurate for final cleanup values. So I just wanted to speak to that. Also, just to speak to the question that Hannah asked, the AOCs do specifically state that there is not going to be, it specifically says cleanup to local background means removal of soils contaminated above local background levels and no leave-in place alternatives will be considered. So in terms of doing that in situ cleanup, on-site burial, or landfilling is also things that we cannot consider per the AOCs.
That would include things like capping and other types of technologies or alternatives.
Thank you, Valerie and Steve. Okay, we have 3 minutes left in this workshop, but what we're going to do is we're going to take a Q&A from Bill. We're going to let Jenny Knack and Rick Moran ask their question from raised hands because they haven't had a chance to ask any questions yet. And then we do have some repeat raised hands, Chris Rowe, Christina Walsh, and Hannah Dye. I'm going to ask you to please send us your additional comments or questions to email or to the stream website that is located on the screen. So Bill, what question do we have from the Q&A, please?
Yes, this is another one from an anonymous attendee, just asking for finality or clarification on this one factor. To confirm, DTSC is saying that it's perfectly safe to live near Santa Susana Field Laboratory, so long as we do not live on the SSFL site. And Valerie, I believe that you spoke directly to that comment earlier, correct? Not from the anonymous attendee, but from another participant in today's workshop.
So the question was asked if I would live there, and I said that I wouldn't have any issue with there. I can't tell you that anything is ever perfectly safe. We live in an industrial world. There are things everywhere, so I can't tell you that. What I can say is I feel confident that we don't have contamination leaving Santa Susana Field Laboratory that result in excess risk to the folks that live in the neighborhood surrounding the site. So that's what I can say, but I'm not going to tell you that it's 100% safe because nothing is 100% safe. That's just.
Thank you, Valerie.
Thank you, Valerie.
Thank you, Bill. Okay, Manuel, who is our next person that we have with raised hands, please?
Next, we have Jenny Knack.
Thank you.
Hi, I want to respond to, I believe it was PJD's question. I understand that it was directed towards Valerie about whether or not it's safe to live near the lab in the surrounding communities. I want you to understand from a community member's perspective who lives within 5 miles of the lab that DTSC explicitly does not accept peer-reviewed, independent, federally funded studies, notably that out of University of Michigan by Hal Morgenstern, that discusses the 60% higher cancer incidence rate in the communities surrounding the SSFL with a, in terms of if you live 2 miles closer versus 5 miles closer. They also fail to acknowledge and incorporate into their analysis the study following the Woolsey fire. The hottest sample in that study was at the furthest extent of the sampling boundary, which was 9 miles away in Newbury Park. DTSC, for whatever reasons, will not accept this independent peer-reviewed data, and it is a detriment to the public to make statements saying that people are safe living in the surrounding areas. This year, the first quarter NPDES stormwater report had lead coming off in over 200 parts per billion. There were 41 hits of PCBs. These are things that are detrimental to public health, and they must be acknowledged.
Thank you, Jenny. Valerie, would you like to respond to that?
I'm not sure exactly how I want to respond to Jenny, to be honest. Steve, did you want to? I see you took yourself off mute. If you would like to.
Take that.
I'm so tired of Steve telling us that there's nothing to worry about because people are dying. Can we not have him do that tonight? Can we please not have him do that? It's insulting.
That's not my intent tonight. My intent is only to explain that we are monitoring the scientific data that we collect at the site in the air, in the soil, in the groundwater. And as we've said, we have not identified anything leaving the site at levels that would impact human health.
You had an air monitor for the first quarter of this year working at 10%. You have uncalibrated air monitors. You have so much issues with the data that you're collecting, and you don't reveal it when someone asks you a question. That's problematic.
I would say that's your opinion on that, but
It's data.
respectfully,
It's not
I
an opinion.
think we have adequate monitoring for the site, and we've demonstrated that there's nothing that should be causing concern to anyone outside of the perimeter of the property. So that's why we do all of that monitoring, is to make sure that the community is protected. And then we do additional monitoring during cleanup to make sure that not only the community, but workers are protected. And we have backup measures to ensure all that. So we are taking the measures to make sure that people are protected.
Why wasn't my question answered?
I'm sorry. We are going to go to the next person, Rick Moran. Christina, if you have a question, we did address your question. If you have another question, can you please type it into the chat? Rick Moran, please unmute yourself and ask your question.
But never answered. I asked that the question I asked.
Okay, this is Rick Moran. This is Rick Moran.
I'm sorry, Rick, I don't want to interrupt you, but we do need to please be respectful of everyone here. It's Rick's time. We are 3 minutes over. Rick, please go ahead and ask your question. Thank you.
Thank you. In holding Boeing, NASA, and the Department of Energy responsible, are these organizations paying for all this analysis, or who is paying for this Department of Toxic Substance Control's work? Thank you.
Thank you, Rick.
So we are under the legally binding agreements with the 3 responsible parties. And as part of those agreements, they are responsible to reimburse us for costs spent in overseeing and reviewing documents and conducting the work that we do on the SSFL project.
Ricky, you still have some time. Did you want to clarify anything?
No, I just wanted to make sure that we know who's paying for this stuff. There's a lot of work going on here, and I hope it's just not the taxpayers that are paying for it.
Absolutely not. Thank you for your question.
Thank you. And that is going to conclude our Q&A. This is not the end of the discussion. We will have an open house on December 10th. And we would also like to invite you to please continue to send us your questions. Does anyone have anything to add from the DTSC team before I move forward? Okay, thank you so much. So thank you everyone tonight for attending tonight's workshop. I want to remind everyone of the ways to stay involved. Our DTSC SSFL webpage contains detailed site documents, which many of you are familiar with. It also includes our contact information and links to join our SSFL e-list for ongoing updates and for more ways to stay informed and connected. We're also encouraging you to visit our Enviro store, which is DTSC's data management system for tracking cleanup and more.
You never
wrap up.
Question.
I'm sorry, please let me finish. Thank you. As we wrap up, DTSC invites you to participate in our future Soil Smarts workshops to continue the conversation and share your valuable feedback. Workshop 2 will be an in-person open house at the DTSC Chatsworth Regional Office, Tuesday, December 10th from 6 p.m. to 8 p.m. Please RSVP in advance by visiting the DTSC SSFL meetings page, which is accessible from our SSFL main page. Please continue to share your feedback and ask questions. The DTSC SSFL project staff through our new STREAM tool. STREAM is the Santa Susana field laboratory tool for response, engagement, and answer management. This system allows community members to ask questions, report issues, or leave comments relating to the SSFL cleanup. Please access STREAM by visiting the DTSC SSFL main page or the STREAM page at the URL on your screen. This slide includes DTSC's contact information for SSFL for more ways to stay connected. Thank you to everyone for your time and your participation in this workshop tonight. We look forward to seeing you at the second Soil Smarts workshop, Tuesday, December 10th, 6 p.m. to 8 p.m. at the DTSC Chatsworth Regional Office. Sign up, please visit the DTSC SSFL webpage and click on the meetings module. Thank you, everyone, and have a great evening.